Have you seen it? That weird glow in the sky on your social media feed? People in Texas, Italy, even the Caribbean, posting pictures of neon skies. No, your feed wasn't lying. The northern lights absolutely crashed the internet, and it's all because the sun decided to crank the volume to 11. Tonight, I'm going to show you exactly why this happened, how solar storms turn our sky electric, and the simple trick you can use to know when your town might be next in line for a celestial light show. Let's start with the basics. Auroras happen when charged particles from the sun hitch a ride on the solar wind and head toward Earth. Our planet's magnetic field acts like a funnel, guiding these particles into the upper atmosphere near the north and south poles. When they collide with gases like oxygen and nitrogen, those gases get excited and release light. That's the stunning green, red, purple, and blue you see dancing across the sky. Here's a quick color cheat sheet. Green is the most common color you'll see. It's created by excited oxygen at an altitude of about 100 to 300 kilometers. Red appears much higher up and is also from oxygen. The beautiful blues and purples, those come from nitrogen. When these colors mix, you can get incredible pinks and whites. That's why every single aurora display is completely unique. So, why are we seeing them so much right now? We are currently in what's called solar cycle 25, and we're heading straight into its peak, the solar maximum. This is the busiest phase of the sun's 11-year cycle, which is expected to peak around mid-2025. More sunspots mean more solar flares and eruptions, which in turn means more auroras. Back in May 2024, Earth took a direct hit from a series of massive solar eruptions called coronal mass ejections, or CMEs. These are like shockwaves of superheated plasma. The result was a G5 geomagnetic storm, the highest level on the official scale. This pushed the auroras to incredibly low latitudes. They were spotted across most of the United States, Europe, North Africa, and even parts of Asia and Australia. It was the most powerful storm we've seen in decades. So if your aunt in Florida posted a picture of pink skies, that's why. So how does a solar storm actually create an aurora? A solar flare, or a CME, blasts a cloud of charged particles into space. If that cloud is aimed at Earth, it usually takes 1 to 3 days to arrive. Here's the key part. This cloud carries its own magnetic field. When that field tilts southward as it slams into Earth's magnetosphere, it couples together like magnetic Velcro. This connection allows a massive amount of energy to pour into our atmosphere, creating powerful electrical currents and causing particles to rain down, lighting up the sky. That's your storm. That's your aurora. How can you know if you might see it? You need to watch the KP index. It's a simple scale from 0 to 9 that measures geomagnetic activity. A KP of 5 is a minor storm. Once you get to KP 6 or 7, the lights start pushing into mid-latitudes. And at KP 8 or 9, they can be seen far to the south. You can track this live. Just bookmark NOAA's Space Weather Prediction Center and check their aurora dashboard. Ever wonder why auroras look like they're moving? Those flowing curtains, rays, and sudden bursts are actually mapping invisible electrical currents snaking through the upper atmosphere. The colors tell you about the altitude. Higher up, the thin air gives oxygen time to glow red. Lower down, where the air is denser, collisions happen faster, so green dominates. And when particles plunge even deeper with more energy, you get those deep blues and purples from nitrogen, often seen at the lower edges of the aurora. Don't worry. Auroras are completely safe to look at, no special glasses needed, but these big storms can cause some trouble. They can lead to radio blackouts, GPS errors, and put stress on power grids and satellites. That's why space weather forecasting is so important for our modern, connected world. So, do you want to catch the next show? Here's your plan. Step 1. Check the forecast. Look for a KP index of 5 or higher where you live. The higher, the better. Use NOAA's aurora dashboard. Step 2. Get away from city lights. Find a spot with a clear view of the northern horizon. Step 3. Your camera will see the aurora better than your eyes at first. Use night mode or manual settings. Try an ISO of 800 to 3200, a shutter speed of 1 to 5 seconds, and a wide lens. If you're using your phone, brace it on a fence or bring a mini tripod to keep it steady, and be patient or as often. Brighten in waves. Right now, during this solar maximum, we are living through a rare window where the sky is putting on a show for millions who have never seen it before. If the sun aims another big storm our way, your street could glow again. So save that aurora link, grab a friend, and get ready to chase the night. Because when space weather goes wild, the whole world looks up together. Thanks for watching. If you enjoyed this journey into the cosmos, don't forget to hit that like button and subscribe for more space adventures. See you next time.